Good morning, everyone. Welcome to week 8 of Essentials of Vector for the unit of Math 13217, Linear Algebra, Vector, and Complex Number. So, as I briefed last week, I'll repeat what I said. So, week 1 to 6 is what we have. What we covered was linear algebra, metrized solution of equation and everything. Then these 3 weeks, so week 7, 8, and 9, we'll be going through vector, and week 10 and 11, we'll be talking about complex number. And week 12 is a bit of revision and some tips for the exam. Okay, let's get going. Before I proceed, I'll talk about the marking of assignment 1. I haven't completed all of it. The reason is some of you are in the extension zone. So if I put it online, the grades and everything, doesn't matter whether I provide solution or not, there is a high chances of breach of those solution, because if you're in doubt, you get full marks. You think, okay, so what I did was right, and it may be passed on to some of the students. So I wouldn't wait along. There is just a few of them. So as soon as that window is over, I bang, bang, bang. I have done everything. I'll just upload and give you all the marks, right? If any concern, please get in touch. I'm happy to address it individually. Right, let's get going. So we'll begin with acknowledgement of country. So we respectfully acknowledge the traditional custodian of the lands on which we work and learn. We pay respect to First Nations people and their elders, past, present, and emerging, for they hold the memories, the tradition, the cultures, and hope of Aboriginal and Torres Strait Islanders people. Aboriginal and Torres Strait Islander people should be aware that this course may contain images, voices, and names of deceased person. Not that it does, but yes. Right, so let's get going. So this is what we covered in week 7. As I said, it's only 3 weeks of vector. So we'll be covering a fair bit of amount with vector. So week 7 was introduction of vector, some Cartesian rectangular form, polar form, some basic application, and vector addition of parallelogram. Okay, today we'll be talking about almost all about multiplication of vector. And towards the end, I'll introduce you a summary, a summary. Please observe that summary, because that's very handy. That's the feedback. This is created by me, but I got very positive feedback because it really bifurcate all of the multiplication. What is multiplication by a scalar? What is a dot product multiplication? What is a cross product multiplication? And a box or a vector triple product. So that's everything in a summary. So that help you, like really distinguish each of them. So let's begin with our first one. Now, the first one is the vector is already covered. The first one was multiplication by a scalar. Right, what I might do is bring this a bit up in this way so you can see it. Looks like a lot better. Okay. Or maybe up as well. Right. So multiplication by a scalar. So what we are saying is, I'll maybe go to that slide. It's a summary slide, but I will quickly take this. So this is what I mean. Yeah, alpha a bar. I'll bring this slide again. It's a slide number 30. So it's mostly towards the end after we cover everything, but you need to be familiar with the first part. This one. So what is alpha? Alpha is a scalar. By scalar, we know it's a real number. By vector, we know is an ordered or triple coordinate pair. If you're talking about 2D plane, it's an ordered pair, x comma y, a comma b, I comma j, 1 comma 2, something like that. But if it is, we're talking in terms of 3 dimension, like a space, the stuff inside your room, the space object, in the space, then you're talking about 3-dimensional. So what it's called is multiplication by a scalar. So there is a vector, A, the bold face is a vector, the italic one is a scalar. So alpha is a scalar and A is, a vector, AXI, AYJ, and AZK as a vector. how it is defined. So you multiply each of it. Alpha with the first one, it's I. Alpha with the second one, J. Alpha with the third one is K. Since it's a summary, I haven't really put ijk as a vector, but is assumed that they are vector. And since it contains ijk, it's classified as a vector. So this is what we covered last week, 2x bar. So you're multiplying all the elements with 2. Yeah. Okay, so let me go back to our. So now I'm talking about second type of multiplication. That is called dot product, right? Dot product. So dot multiplication of two plane vectors, so two-dimensional vector or three-dimensional vector. Okay, so A in a bold face is AA bar. Okay, so that is the vector, right? The magnitude and the angle. The magnitude, and the angle. By the way, this is called the polar form, which we covered last week, right? Italic form is again a scalar, A dot B. So vector A dot vector B. If you don't want that, just write C is equal to vector A dot. This is what you can write on a piece of paper, right? So in the polar form, the multiplication is multiply the magnitude and the difference of the angle. Now, it doesn't matter whether you are going alpha minus beta or beta minus alpha because cos absorb the minus sign. So what I mean by that, cos minus theta is the same as cos theta, isn't it? Right? Because the first quadrant and the fourth quadrant, theta is in the first quadrant, minus theta is in the fourth quadrant. ASTC, the first and fourth quadrant, their cos is positive, so they gives the same result. Okay, right. And it's also called in general theta. Okay. So this is how it's defined. You keep the magnitude outside and difference of the angle if it is given in the polar form. Very simple. We'll also say in a rectangular form or the Cartesian form. Okay. But if you're talking about A dot A, so vector A with vector itself, what it gives you, you can say mod A, cos angle between them is 0 degree. Because the vector angle with the same vector, what is the angle does it form? 0 degree. Cos 0 degree is 1. So what it gives you is A square, or you can say this as well. So A dot A is A square. So if you, what is mod A? Is the magnitude of A. So if you want the magnitude of A, you can say the square root of vector times vector. I mean, by times, I mean dot product. So that, as we can see, in this one, there is nothing ijk. There is a scalar output. The C is a scalar output of A dot B. Okay. Right, let's talk a bit more about perpendicular and parallel vectors in terms of dot product. So if A is perpendicular to B, what is the angle does it form? So perpendicular forms the 90 degree. So A dot B is AB cos theta, right? Theta is the 90 degree, cos 90 is 0, 0 times anything is 0, so you got a 0. So if it is perpendicular, the dot product of the vectors is 0. The reverse is also true. It's called if and only if and then statement, if and only if, right? Just to put a context, bit more context to it, what happens with if and only if? It's true on both the sides. So for example, I'll give you a very famous quote about Pythagoras theorem and right angle triangle. If it is a right angle triangle, the Pythagoras theorem holds. So therefore the hypotenuse square is the sum of the square of the remaining two sides. Or in other words, c square is equal to a square plus b square in standard notation. The reverse is also true. So if c square is equal to a square plus b square, you can confidently 100% truly say that the triangle is a right angle triangle. Okay. Now that's if and only if example. I'll give you a simple example. Let's talk in terms of geometry. I can give you a real life example as well. And then I'll give you a geometrical example. It's true one way, but not the other way. For example, if it has rained, the roads will be wet, right? But the reverse, if the roads are wet, can you say it would have rained? Not always. It could be some moisture in the morning. It didn't rain, is a lot of humidity, right? Or it could be someone, paving, putting waters to the pavement for the plants and everything. They would have, drenched some water on the road and the roads are wet. Or it could be some water tank, a fire truck. Like there could be many situations then the water is on the road. So if the roads are wet, it does not necessarily mean it would have rained. That's a real life example. Now, in terms of a geometry, I'm just thinking of rhombus and parallelogram and everything. Okay. For a parallelogram, if all the, okay, for a square, which is a type of parallelogram, of course, all the angles are 90 degrees, right? We know that. So if it is square, it's all the angles at the vertices or the points A, B, C, D is 90 degree. But for a parallelogram, if all the angles are 90 degree, it's not necessarily mean a square. It could be rectangle as well. Similarly, you can say for a square, all the sides are same, right? But for a parallelogram, if all the sides are equal, it does not necessarily mean that it's a square. It could be rhombus as well. Similarly, you can talk in terms of the diagonal, bisecting into 90 degree. They all bisects, right? They all cut into half. But if it's 90 degree, it could be, like again, rhombus or a square, right? So if and only if statement. Okay, so just bear that in mind. It's part of logical or Boolean algebra. That's what we call it. The reason I mentioned to you, if you're teaching, you might encounter, I'm not sure if we covered that bit, but you might have learned that in school, high school, and if and only if example situation, the Boolean algebra logical statement. Okay, I'll come back to here. The reason I was dragged there is because of this. Let's change my pen color if I can. Okay, right. Right. So alternatively, if A dot B is 0, so if the dot product is 0, we can confidently say that the vectors are perpendicular to each other. So it's a if and only if they're perpendicular, dot product 0. The dot product 0, they're perpendicular. If and works both way. Right. So up in the earlier slide, we said that A dot B is AB cos theta. Right? So A dot B is AB cos theta. So if you wanted to find the value of the angle between two vectors, so cos theta, you make cos theta as a subject. They are the scalar value. It will be divided. So if you wanted to write in terms of the vector form, like I would write like this, A dot B divided by mod A mod B, where theta is the angle between both the vectors. Okay? Right. That was about the perpendicular. Now let's talk in terms of the parallel. Say if the two vectors are parallel, what is the angle that they form? They are parallel like this, right? They are going in the same direction. Let's put them in the same direction, right? So A dot B is AB cos theta. Angle between parallel vectors is 0. So that will give you AB cos 0 or simply AB or mod A mod B, right? In other words, you can also say that cos theta is equal to 1. And we know that, right? Okay, cool. Let's put an example. So given two vectors, A is equal to 4 angle 30, B is equal to 3 angle 60, determine C. I mean, this has to be not a bold C, just a normal C, yeah? Italic C, yeah, not a bold one. Yeah? A dot B. Mode A is 8, mode B is 8, or magnitude A if you want to be very specific. A dot B is 24, find the angle. So we got two questions here. Okay, you are getting the first one. the dot product. And if you know the dot product, find the angle. Right. Let's get along with the first one. Okay. So C is equal to A dot B for angle 30 dot 3 angle 60. As we have seen, it is 4 times 3, 12. And difference of angle, I would prefer 30 minus 60. 30 minus 60 is 30. So 12 cos 30, right? Let's write it here. Okay, cos 30 is root 3 over 2, 12 times root 3 over 2, or we can safely say 6 root 3. So that's the A dot B. Part 2 is not the same as A, it's a different one. So let's do the second one. What we know, A dot B is equal to mod A mod B cos theta. Now A dot B is 24, 8, 6 cos theta. Okay. So cos theta is half. That means your theta will be 60 degree or 120. Okay. Cool. So yes, 60 or 120. Reason being 60 or 120 is it could be in sorry, no. No, it's fine. That's 60, sorry, because 120 will be 120 will be second quadrant. Second quadrant cos is negative. Sorry, just 60. I don't know why I thought of 120. If it was sine, yes, 60 or 120, but we are not talking about sine here. Just thinking about cos here. In general, the angle between two vectors can be acute or obtuse, so up to 180 is fine. When we talk cross product, the next upcoming multiplication, we'll be talking about sine theta. And with the sine theta, the answer could be 60 or 120. Cool. Let's do the next one. I had some space, but I think this is fine. Yeah, we didn't need the space. Good, good, good. I prefer to do it on a one slide. I'm not sure how you guys prefer it, but the more is on the same page is easier for me. So I'm not flipping back and forth and less chances of error. And this is some tips which I have given in past as well and keep giving it. Always start, if you think it's a longer question, don't flip the page. Always start from the left-hand page and you carry along. So if you're starting in the middle of the right page, then you got only half page and then you're flipping in and out and the chances of error increases a lot. Right. So we continue with the dot product, but now we will talk in terms of the xy coordinate or the rectangular form or the Cartesian form, right? So vector A is AXI AYJ, B is BXI BYJ. So C, which is a scalar, A dot B, what you do is AX ABX plus AYBI, okay? So typically the dot product, I'll explain it here, but again, just to be short on it. So what is the angle between X and Y axis? 90 degree. So X in unit vector is I. J is the unit vector for the Y direction. So the angle between I and J is 90 degrees. Therefore, I dot J is 0 and J dot I is also 0. Okay. Now let's expand it traditionally. So what would have happened? Vector A dot vector B. So what we have? AXI, AYJ dot BXI, BYJ. How would that work? AX, BX, I dot I. Oops, very good. Went too fast. Okay. Plus AX, BY I dot j ay bx j dot I plus ay by j dot j. Now, as I mentioned that I dot j or j dot I will be 0. So this thing will be 0. This is gone. This is gone. I dot I, the vector with itself, I dot I will be 1. J dot j will be 1. So what we are left with is, this is 1. Yeah, this is 1. This is 1. What we are left with is bx plus ay b. And this is what we have. This is a long one, but you just moving forward, I mean, this was FYI or to increase your understanding, but moving forward, just the multiplication of x part plus multiplication of y part. Many of the literature, what they have provided is in terms of the coordinates. So you can also find that a dot b will be something like ax, ay. They're written in terms of the coordinates, dot bx, by. No ij, just the coordinates, yeah? And that's the same way of ax, bx plus ay, by. Cool. If you want cos theta, which is a dot b over magnitude a, magnitude b is ax, bx, ay, by divided by magnitude a and magnitude b. Now, same thing, the perpendicular and parallel stuff for dot product in Cartesian form or rectangular form or xy form. If A is perpendicular to B, we now know that A dot B is 0. So AX, BX, AY, BY is 0. If the vectors are perpendicular, and the reverse is also true. Okay. But if they are parallel, right, what happens? Cos theta is this, which is 1. So therefore, A dot B or AX, BX, AY, BY is magnitude and magnitude B. Pretty much the same thing. Yeah. We're just giving different viewpoint of watching the same information. So we talked about the polar form with the magnitude and angle form. We talked about the XY coordinate form. Okay. Okay, let's look at one more example. So given a vector A, 4i, 3j, B is 3i, 5j, 3i minus 5j, determine, again, this is italic C, not a capital one, A dot B. Find the angle between A and B. If A is perpendicular to D, xi 4j, again, J is capital, not an italic. Yeah, the bold capital. Determine the vector D. Okay, let's start with the first one. That's very easy. A dot B. All right, 3j dot 3i minus 5j, 4 times 3. Remember, ax, bx, so that's a 12. 3n minus 5. 12 minus 15 is minus 3. That's it. So the first one is minus 3. Okay. Cos theta is A dot B divided by mod B. A dot B is minus 3. This one is square root of 25. 16 plus 9. 16 plus 9. And this one is 34. 9 plus 25. That's it. Minus 3 over 5 square root 34. Right? That's your cos theta, but we want the angle. So we want the theta, and which imply theta is equal to arc cos or cos inverse of this. Okay, since there is a minus, as you can see here, that will be more than 90. So if you calculate in your calculator, it will be 95.996 approximately. So you can imagine, if A is going here, that's your 90 degree. Your vector B is somewhere here, leaving you 96 almost, right? Okay. Now the third one, as I said, I'll squeeze it in. You can always make your better fair notes, okay? I like to do it on the screen rather than bringing the typed information, right? Because type information doesn't work that much good with math, you know? So I was doing it in past, and in fact, I'm doing it step by step rather than flashing math type one, yeah? Okay. So A is perpendicular to D, so what will happen? Vector A dot D is 0. A, which is 4i 3j dot D. D is xi 4j. Is 0. Don't write a 0 vector there, yeah? Because it's a scalar, so you don't know the vector over there, okay? So that will be, can I say 4x plus 12 is 0? And if 4x plus 12 is 0, x is minus 3. But your aim was not to find x. Your aim was to find a vector. It is finally your answer will be vector D is equal to minus 3i plus 4j. And my touchpad has become really sensitive. Okay. Now, if you look at that, your A is 4i 3j, right? And your D, see, 4i 3j. This is minus 3 and 4. 4 times minus 3 is minus 12. 3 times 4 is 12. 12 minus 12, oh, 0. So A dot D is 0. So, of course, we will show all the steps and everything, but whenever you want to find a vector which is perpendicular, so there is a given vector, okay, you want to find some vector which is perpendicular to it, simply swap x and y and give something minus to that one. The reason you'll have two vectors to it, let me go to the next slide and explain that bit. Okay. Right. So say, for example, your A is what? 4 and 3. So x is 4. This assume is 4i 3j. It's 4 comma 3. Yeah, it's the same way 4 comma 3. So that's your vector A. Okay, that is your vector A sitting up here. Now D is perpendicular to A. So what are the vectors that could be perpendicular to A? Again, let me change pen color, bring it to blue. So somewhere here, that could form a 90 degrees. So you can say vector D is perpendicular to it, or vector minus D is also perpendicular. So we figured out that D, what was D? Was minus 3i plus 4j is perpendicular. We can also would have done 4i 3j dot 3i minus 4j. You swap x and y coordinate, that's fine, but give a minus any way you like. This one, the dot product will be still 0. Because that's also 90 degree. 90 degree can go in either way. So there is a vector. You are talking about a perpendicular vector. Now you point the vector here and the other side is minus, right? So if you are like a multiple choice or something, or a very short question, or you're verifying the answer on any situation, if you want really quick fix, swap the x and y and give a minus. Okay. Good. Let's keep going. Many blank slides. Okay. Now that was all about dot. Now we will talk about the cross product. Okay. cross multiplication or cross product of two plane vectors. Again, we'll start with polar and then we'll go in the Cartesian or the rectangular form as well. So A, now, I'm not sure how many of you know that term, but it's called right-hand thumb rule. Yeah, refresh your memory if you've seen that thing. So what happens? Why it's called right-hand thumb rule? So if a vector is A is like this, and okay, vector A and vector B is going like, I'm not sure how many, let me put it this way, right? That's a vector A, that's a vector B, A and B vector, right? So the A cross B is a right-hand thumb rule. So that goes like that. Tweaking of screw. Ping, 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 or the other way. Dum, dum, dum. Irrespective what direction you are going. So your C can go up. It can also go down. So if you got two vector, A cross B is a third vector which is perpendicular to A and B both, and it's going upward or the downwards direction. Okay, so you got vector A with a magnitude A and angle alpha. B is B and beta. C vector, remember this is a vector, not a scalar. So we got the boldface. C is A cross B, which is AB. Cap A cross cap B, which is the unit vector along with the direction of A, and unit vector along the direction of B. It will be given by AB sine beta minus alpha and C cap, or you can simply say sine theta. C is a new vector perpendicular to both A and B, because like I said, where is it? Yes. Okay. So again, this is A, B, doesn't matter which is A and which is B. The C vector can go like this, or it can be going in a downward direction, right? The downward direction. Okay. So it will be perpendicular to both. Imagine C is your Z and AB is your XY. Now X and Y is on a floor, XY coordinate. The Z can go up, can go down. If you're sitting on a first floor, your Z can go down as well. If you're on a ground floor, it can go underneath the surface. So that's your C going downwards. It can go upward as well, but perpendicular to both X and Y, perpendicular to both A and B. So A cross B, the vector A cross B is perpendicular to both A and B. And similarly, if you want to find sine theta value, it's sine beta minus alpha, or we can say is A cross B over magnitude of A and B. Right. Okay, how do we derive that? So you got this relation. Not that one. I would just. What do we got? We got A cross B is mod A, mod B, sine theta, and C cap. Okay. Now, if I wanted to find the value of sine theta, which is a scalar or a real number, I'll apply mode on both the sides. Or the length, if two vectors are same, say it this way. If two vectors are same, the length will be same. Okay, so this will be left is A cross B. You don't need double length, sine theta, and the length of C. Now, length of C is a unit vector. Length of C will be 1. So that will simply give you this result up here. Okay, once you make sine theta as a subject. Cool. Again, the same perpendicular parallel stuff. If it is perpendicular, then C is equal to A cross B. Sine 90, that will go. So in the dot product, perpendicular was 0. Up here, parallel will be 0. So mode of A cross B or magnitude A cross B is simply AB if they are perpendicular. Right? And if they are parallel, that will be a 0 vector. Please understand the difference. We are talking about 0 vector here, the bold face 0. Why? Because A cross B is a vector. It's a vector which is perpendicular to both A and B. Let's take an example to understand this. Given two vector A and B, determine C is equal to A cross B. We make up the same data just to put a comparison. Right. Let's do the first one. C is equal to A cross B. What was the definition of cross? You multiply the magnitude, the sign, difference of the angle, and the C cap. So 4 times 3 sine 60 minus 30 and C cap. Okay, that will leave sine 30. Sine 30 is half. 12 times half is 6. So vector C, which is A cross B, is 6 C cap. Correct? You can also come up with some vector D, like I was saying. If you do it the other way, B cross A, it will mean the same thing, but up here will be 30 minus 60 C cap. So vector D minus 6C cap. So it's the opposite direction. Like I was saying, C is going up, then D will be going down. Yeah. Again, perpendicular, but going down. The positive z-axis and minus z-axis. Okay, the second one. We want the angle. So you can start like this. Vector A cross D is equal to magnitude A, magnitude B, sine theta. This is 24, 8, 6 sine theta. And therefore sine theta is half. And here you can have two values. This is where I was getting mixed up a bit. Or you can say 30 or 150. Why? Because sine theta is half. Arc sine vector angle between two vector can be 30 or 150. Cool. Okay. Now, let's understand this in terms of xy coordinate, ax, ay, bx, by. Okay. What happens here? So I'll draw a circle. Let's imagine I is here, A and K. If you come in the same direction, so I cross J, it will be K. J cross K will be I. And K cross I will be J. But if you swap the direction, so what's a different color? Light blue. If you swap the direction, right? I cross K, it will be negative J. So you say here, I cross K is negative J. K cross J, right? K cross J is negative I. And J cross I is negative K. Okay, so you got all the three. Ij is K, Jk is I, Ki is J. The third one, if you multiply I with J, is K. Doesn't matter where you write it or not plus minus direction or something. It depends how you are drawing it. But just put it this way, I, J, K, same sequence, I with J, cross product is K, J with K is I, K with I is J. The same order. If you swap the order, so rather than 1, 2, 3, so 1 times 2 is 3. If you are saying 2 and 1, J cross I is minus 3. 3 and 2 is minus 1. 3 and 1 and 3 is minus 2. Yeah. Okay. So having got that in mind, let's explain or understand this in terms of, I mean, it's there, but I'm just, trying to prove it. So same as per the dot product, we have 4 numbers. So if I expand this, I will have ax, bx, I cross I plus ax, by, I cross j plus ay, bx, j cross I. Don't change the order. Ay, by, j cross j. Okay. Now I cross I. Now if you go back the previous slide, just before the example, if it is parallel, then the cross product is 0. So I with I, same vector. A vector with itself is always a parallel vector, right? So what I can say here is, this will be 0 vector. So that's gone. This will be 0 vector, right? I cross j. What is I cross j? Just above. I cross j is vector k, right? J cross I is over here. J cross I, the first one. J cross I is minus k. Okay, so what we are left with is ax by k, right, minus ay bx k. Once you combine it, you would have this ax by minus ay bx k. Shortcut. What is a shortcut? We don't want to do this longer way. Shortcut. First with the last, minus last with the first, right? First last, ax by with the real number. Ax and by are real number. They are scalars. Doesn't matter how you write it. 2 times 3 is 6. 3 times 2 is also 6. So they are the same. But vector algebra, matrices algebra. So see, I'm putting more terminology to it, so we understand why 2 times 3 is 6, 6 times 2 is 3. I mean, 3 times 2 is 6, but it's not true with the vector all the time. It's not true with the matrices, in general. Yeah. So again, normal algebra, we call it abstract algebra, right? That's fine. 2 plus 3, 3 plus 2, 2 times 3, 3 times 2. Up here, vector A cross vector B is not same as B cross A, right? So you can't swap ij. We just got it here, like this one. Ji is minus k, ij is k. Different, right? Because there's a lot of direction and the stuff is involved. Yeah? Okay. Let's keep going. Now, the same parallel and perpendicular in terms of x and y. So A is AXAY, B is BXBY, of course with I and J. Then C is this. Sine theta is the magnitude of A cross B divided by mod A mod B. So AXBY, magnitude of that. So K magnitude. IJK, they are unit vector. So by definition, unit vector are the ones whose magnitude is 1. So if you think about mod of k is 1 because that's its definition. Mod of I is 1, mod of j is 1. Okay? Right. And again, you can think in terms of the dot product as well if you wanted to. If they are parallel, what happens? Sine theta is 0. So when you make this as 0, the denominator times by 0, right? So let's say if I make this 0, that means only the numerator is 0. See, the output of a quotient is 0. That means always numerator is 0. Denominator cannot be 0, otherwise it becomes undefined. So if I say A over B is 0, it means simply A is 0. B has nothing to do with 0 or non-zero. Yeah, it's only the numerator who produces 0 outcome. So this is a ratio. Like just think of P over Q is 0. If P over Q is 0, it obviously means your P is 0. Right? Q has, because 0 times Q is 0. Yeah? So if it is parallel, ax by minus ay bx is 0. And if it is perpendicular, right, then we know that sine theta is 1, and therefore the numerator is the same as denominator. Okay. One more example, similar example, but rather than dot, we are talking in terms of a cross. Right. So let's put what we learned into context. So A is 4i3j, B is 3i minus j, vector C is A cross B. Right. So first one, vector C is A cross B. By definition, we know what is it, right? First last and last first. Okay, so I'll write it here. 4i3j cross 3i minus. I'll just write one for convenience. You don't have to. I'm just writing it so we can compare it. First and last, 4 times minus 1 plus 3 times 3. Okay, 4 times minus 1. So minus 4 plus 9 along with k. Okay, and that is minus 5. Oh, sorry, there is a minus here. So that's a 9. It's a similar in terms of the determinant. We haven't get rid of the determinant yet. It will come back. Yeah. 4, 3, 3 minus 1 along with vector k. How do you expand it? Minus 4 minus 9 along with vector k. And that's same as minus 13k. 13k. Okay. Find the angle between A and B. So we use the sine theta. Magnitude A cross B is equal to magnitude A, magnitude B, sine theta. So this is minus 13k magnitude. See, let me tell you one thing. If you mix it up with the absolute value, this minus 13, when it comes out of this sign, which we call as a magnitude, right? It should be, in absolute value, it will be converted to positive. Up here, we are talking about the length of a vector. So only the k goes away. Because when I'm talking about the length of a vector, say, for example, alpha x bar length or its magnitude is alpha times x bar. So what happened in our situation, minus 13k magnitude is minus 13 times by magnitude of k. Magnitude of k is once a minus 13. Yeah. Okay. Magnitude A. Do we have magnitude A? No, but we know it's 4 square plus 3 square. It's the same number, so 5 and root 30. Yeah. This is 9 and 1, so it's a 10. Sine theta. Okay. So this is minus 13. So if I make sine theta as a subject, 5 and root 10. Yeah. And theta will be, since it's a minus, it's only 1 minus 55. Okay. Now, B is parallel to D. What happens to the parallel vector in terms of cross product? The cross product will be 0. So the third one, we have vector B is 3i minus j. Vector B is 6i plus yj. Okay. B is parallel to D, and therefore B cross D is zero vector. Another cross product. How do we obtain cross product? Remember, First with the last, right? 3y minus last with the first. It's already a minus. The minus will be plus. Plus 6. Vector k is a 0 vector, right? This is to compare. So what I can say that 3y plus 6. K is not a 0 vector. So 0 would have happened because of the multiple. So the front part is 0. Don't write 0 vector here because that's a scalar. Alpha x bar, right? If alpha x bar is 0, either alpha is 0 or x bar is 0 vector. Yeah. In our situation, alpha k bar is 0. Alpha is 3y plus 6. Since k is not a 0 vector, this will give you alpha is equal to k is not a 0 vector. K is a unit vector in the z direction, right? The perpendicular A cross B direction. So that's not a 0. That's not a 0 vector means origin, right? So it means the multiple, the scalar up front is B. So that means y is equal to minus 2. Don't forget to write the final answer, that vector D, which was minus 2j. That's the vector D. Cool. So I hope you had some time practicing this question. If not, still pause it here and do it. So you got technically 1, 2, 3, couple. I'll explain it separately again if you are not sure. So in the first part, what you are doing is A cross B, obtain A cross B and have a dot product with vector C. In the question 1 second half, you're doing A cross B, you're doing C cross A and having a cross of both. In the second question, what you are doing is A cross B times it with C vector and then C times it with or the cross product with A cross B. So give it a go and pause the recording if you needed to. Resuming our working now. Okay, so first one. This is the same question from earlier one, the AB at least. So 4i plus 3j cross 3i minus j. Right. First with the last with the first. And ij will give you k. And you can do the determinant. So pretty much what we just now did. It was this vector. See, say 4i, 3ij, same minus 13k. Right, so I'll just copy that minus 13k. Right, now I'm having A cross B dot C. Dot C. So minus 13k dot, have the dot really like, make it bold dot, yeah? So it looks like dot. C, which is I plus 2j. Now, I dot k will be 0. So is k dot I. That will be 0. Minus 26k dot j. That is 0 minus 0 is 0. That's it. Yeah. With the second part, let me obtain, I mean, this is one of them. Second part of 1. Yeah. C cross A. So let me obtain C cross A. Because I already have A cross B. So C cross A is I plus 2j cross 4i plus 2j. First with last, last with first. So 3 minus 8. 3 minus 8. Just making sure. No, sorry. I plus 2j C cross A. Maybe that one my walking is wrong. Anyway, it doesn't matter. It will have a k. So that one is 3 minus 8. So can I say minus 5k? Yeah. Now I'm going to have A cross B cross C cross A. This is outside, not inside. Okay, so that one is minus 13k cross minus 5k. K cross k is a zero vector. So remember to write a zero vector, not just zero. With the dot product, it's a zero because dot product output is a scalar. With the vector product or a cross product, the output is a vector. So make sure you write a zero vector. Okay, cool. So that was first part. Now the second one. I'm going to split it into two parts. So first, I'm going to do A cross B cross C. A cross B is minus 13k cross with I plus 2k. Now, leave the minus 13 outside. A cross I plus minus 26. You don't need plus and minus both. If you want, simply say minus 26. K cross J. Remember, ijk, k cross I will be j. Minus 13j. K cross j, I, j, k cross j will be minus I. Right? So minus 26 minus I. We prefer to write I first, so that will be 26I minus 13j. So that is our second first part. And now I'll swap the vector C cross A cross B, I cross 2j minus 13k. That is okay. Ijk, right? So it's not I to j, j to k, and k to I. It's I to k. So it's minus j. Can I say 13j? J to k is simply I, so minus 26I. If I keep a negative outside, so what I obtained is A cross B cross C is not same as C cross A cross B. In fact, it's the opposite. We got a very good explanation for this is, like I explained, if you got two vectors, A and B like this, the third vector or the cross product, if you got two vectors like this, the third one, cross product is going up. If I swap the order, that's going down. The screw, and that's why I always talk about the right-hand thumb rule. If you put it like this, it will go boom, 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 it will go up, right? If I swap it, it will go down, right? So simply it will have positive z-axis or the negative z-axis and will carry a minus sign. If you want, you can also go one more step and verifying A cross B cross C is not same as A cross B cross C. So leave the A apart and B and C. Yeah, you can also do that and they'll be entirely different, not just opposite, entirely different. Okay, so let's talk about vectors in 3 dimensions. So far, what we have dealt in is only 2 dimension. Now we talk about vector in 3 dimensions. So A, we'll have AX, AY, AZ, right? So this is 1 row, 3 element. This is 3 row, 1 element. When you multiply this matrices, you'll have 1 cross 1 or like this. Yeah. Same with B and C. So here K is the 3rd dimension, is not the cross product of I and J, right? And when you talk about the dot, first with first, second with second, third with third. Yeah. About cross is a fancy determinant. So vector A cross B, vector A cross B is IJK, AX, AY, AZ, BX, BY, BZ. And then you expand it the same way which we did, extending 2 columns, having IJ and K, and then expansion it here. Now, this is called box product ABC, A dot BC, B dot CA, and AB dot C, right? Where you are having all the vectors AX, AY, AZ, BX, BY, BZ, and CX, CY, CZ is determined. Again, how do you expand it? The same way what we learned. Okay? The same way what we learned, expanding 2 columns. Okay? This is the last type of vector triple product. A cross B cross C is A dot C. Remember, it's a scalar along with vector B and BC. So what you do? First with third one in B and second with third one in A. So C is having a dot product with both of them. A dot CB minus B dot CA. Now, this is the same summary that I was talking about. Okay. Alpha with A bar. A scalar and a vector. Scalar and a vector. Multiplication by scalar. Alpha is a scalar, and A, I already talked about this. This was last week content. The output, since it's content I, J, and K, is a vector. Okay, A dot B dot multiplication, dot product, or scalar multiplication, because the output is 7. So you got vector A and vector B. I'm talking in 3 dimension. If it is 2 dimension, even easier. Yeah. Right. So what it is? AX, AY, AJ, sorry, AXI, AYJ, AZK dot BXI, BYJ, BZK. First with the first, second with the second, third with third, right? Everything plus no IJK, absence of IJK, or any vector indication will produce an outcome with a scalar outcome. So you started with 2 vector, you talked about his multiplication, but the multiplication outcome is a scalar. While in that cross multiplication or vector multiplication, you started with 2 vector and outcome is also a vector. This is just a summary, right? So what you do, if you're talking about I, the first part, then AYBZ minus BYAZ. With the J, you talk about the minus, or you can swap it, AXBZ minus AZBX. And with the K, AXBY and AYBX. So same matrix is formed. The way we expand it. Yeah, nothing new here. With dot n across, okay, if you got AX the same way, then it's we are talking about a determinant without any IJK, so the outcome is a scalar. Now there is some links here. Slide 13. Let's see what I'm scrolling. Yes, okay. There are 2 here. Yeah. It was your bad. com, as you just scalar for any strings and towards the what it is, and similarly how you implement that the same as all of this, right? And then there is this formula, and the determinant form way of writing it, geometrical interpretation. That's more important. That's the reason why I'm bringing it on the screen. Okay, so what it is, to understand the geometrical interpretation of the scalar triple product, that's the value of scalar triple product. It's the volume of parallel part, where A, B, C are the adjacent side of the parallel part. So it's a parallelogram raised to 3D, where the base is a parallelogram. Yeah, it's been raised to 3D. It says low system resources. Okay, so I might have to close some of my stuff. So I can show you. It should be fine now. Right. Right. So I was saying, is so A and B are the base, and C is the height of that shape. So that's what it represents. See, A and B are the base, and C is the angle, and that's a nice stuff rather than just talking about definition and example. It's good, but it's not complete, I would say. Yeah. And then a lot of explanation, right? So please spend some time reading it. There is some example. I can leave the link in the chat. I'm not sure if the chat will be captured or not when you look at the recording. But if you struggle with it, if yeah, then please let me. I can leave it on a Moodle as it is. Yeah, so don't worry. Yeah, you'll be fine. There's some small quiz to check. This is different parties used. You know, yeah. Again, please. Uh, so just don't treat it as a vector scalar basic question. It's really more right. Okay. Okay, so let's do vector element. First question dot C and D X, Y, and Z depend on A plus D. Now the second part is a bit intense. Okay, you will see why. It refreshes our concept of Gauss elimination. So I'll explain it when we reach there. Let's talk about the first part. Okay. A dot B. Okay, first with the first. That is 12 minus 3 plus 2. And that will result into 12 minus 3 is 9 plus 2 is 11. It's a scalar? Yes, it should be a scalar. Okay, we don't know it's right or not, but as long as it's scalar, we are 50% sure that that looks right. A cross B. Right. So you can always talk in terms of the determinant. IJK is 4, 3, and 1. 3. It responds literally after a couple of minutes. Anyway, okay. Now you can expand it however you like. I got my own way, which I don't want to confuse, like I said earlier. So that will be 7i minus j2 minus 8 minus 3. So minus 5j plus minus 4 minus, so that would be minus 13k. Yeah, this is my A cross B. So we did the first bit. We did the second bit. We still have this vector triple product. A dot B, A cross B dot C. Now you get two choices of doing it. Either you can go for that matrices thing or something. So matrices thing will be vector A. So that was 4, 3, 1 minus 1, 2, and 1 minus 2, 1, and expand it whatever you like, and that will be 4. So that's one way of doing it. If you find that's a bit longer, which I do, then have A cross B. You already got A cross B. 7i minus 5j minus 13 dot C I 2j and k. That is 7 plus 10 minus 13. 17 minus 13. That's 4. Verify. Yeah. Okay. Now, the second part of the lower part. What is the second part? Your vector D is given with 3 unknowns. A cross D is given to you. Okay. You need to determine D. Okay. So what we'll do, we'll obtain A cross D, like normally we do with the determinant form IJK. First row is IJK, second row of A, that's 4, 3, and 1, and third row of D, which is X, Y, and Z. We obtain that, equate it to or compare it with the right-hand side, 5i minus 2j plus 2z. So you'll get 3 equation, 3 variable, 3 equation, goes Jordan. Right, the back substitution. So we obtain the metric form of it. Once you get the equation, it's up to you however you wanted to solve it. So you can go with the Ax is equal to B form and obtain A inverse, X is equal to A inverse B, or the Kramer's rule, or Gauss-Jordan, Gauss elimination, couple of methods. I will have Gauss elimination here. So let's do the first step. Let's talk about, first of all, A cross D. That's A is 4, 3, 1, and D is X, Y, and Z. So what I get here, I with dz minus y, A, um, minus 4z plus x, a 4y minus 3x. Just write it clearly so minus is visible. This is my a cross d. But in a question, it says that a cross d is 5. I just write it a bit nicely so we compare the equation. Yeah. Or if you want, I can say I times 5, the same thing. I, same thing. So just as long as you're comparing it correctly. Okay, with what do you got? Equation 1, equation 2. Okay, equation 1 and 2 from 1 and 2. Two vectors are same only if the x component, the y component, and z component are same. So what you got? 3 z minus 5 is 5. I got minus 4z plus x is minus 2. And 4y minus 3x is 2z. Now I write a bit in equation form. So I'll see. Remember I told you earlier as well in Gauss elimination that first equation does not mean the first equation. You decide what is your first equation. My first equation I prefer with x, and the simple the better. So what I will do, I will choose x, and again I'll write it a bit nicely, plus 0y minus 4z is minus 2. That's my first equation. So I call third because I already got 1 and 2. Second, doesn't matter. So I'll leave the 0x, 1y. That's my second equation. And the third, keep the x, y, z on one side. Right? Once I get this, my next step is I got the equation x 0 y minus 4 z minus 2 0 x 1 y 3. I wrote 1 with purpose so we don't forget that. Whenever there is a gap, include 0. Right? From here, I will form the augmented form. Okay. So what is the augmented form? 1 0 minus 4 is minus 2. 0 minus 1 3 is 5. And minus 3 4 minus 2 is 0. The Gauss elimination, you got the leading one, everything. You need to have 3 zeros. So if I do it here, they all should be 0. You got one of the 0, awesome. You just need to make this one and this one as 0. Okay, so let's try that. So the third row will be very easy. So what I'm doing two processes simultaneously. My third row will be row 3 plus 3 times row 1. Because I got 1 in the first row and third row is minus 3. The same way which we explained in Gauss elimination. Okay. And at the same time, I will change my row to yes, minus. I don't want minus 1. I want plus 1. Yeah. Okay. So 1, 0, minus 4 is minus 2. 0, 1, 3. Since I changed the sign, make sure we are changing it everywhere. And this one is 0. This one is 4. That becomes minus 12. Minus 2 becomes minus 14. Is 0 plus 3. So that's minus 6. okay, from here. Right, since I got that, perfect. Now, what is my next step? I got 4. I need to make that one 0, right? So my row 3 will be row 3 minus 4 times row 2. So first row doesn't change. 1, 0, minus 4 is minus 2. The second row does not change. Third row 0 and 0. I had minus 14. I'm adding plus 12. Minus 3 times minus 4. Yeah, so that will be minus 2. I had minus 6. I'm adding 20 to 8. So that will be, can I say 14? Yes, I can say 14. And that's it. Once you reach at this step, the back substitution, right? So minus 2z is 14, leaving you z is minus 7. Make sure you are doing it correctly. If your z is wrong, your y and x will look horrible. Not just wrong, horrible. Okay? Y minus 3z is minus 5. Right? Plus minus 5. And y will be minus 26. And third equation, x minus 4z is minus 2. Plug in minus 7, so that's like 28. And that 28 will be positive, goes on the other side because negative. So x minus 30. I got my x, y, and z, and therefore, see, x, y, z was a part of my question. I wanted to find vector d. So just bear in mind what x, which is minus 30i, y, which is minus 26j, and z, which is minus 7k. That is my vector d. Okay. That's it. That's it for today. Yeah. Hope the last one makes sense. That was in 3-dimension. Everything earlier was in 2-dimension. Any questions, please reach out. We got one more week of vector, and then we got 2 weeks of complex. Before we go into complex, please make yourself very comfortable with I, J, K, and everything, because in complex as well, you will have I, which is imaginary number, square root of minus 1. So don't get mixed up with I as a vector and I as a complex number. Yeah, the more clearer you are, the better it will be for you. That's it. Thank you very much, and I'll see you next week. Take care.